Hello everyone, this is 2.5, the second part of it. We started this, I don't know, Monday of last week before Thanksgiving break. Here is the homework assignment for it, right there listed at the top. If you need to pause, go for it. But we talked about rational functions. Two things that you should have in your brain, burned in, not burned, but whatever. 1 over x is the boomerang, yeah? That's what he looks like. 1 over x squared is a volcano. He's like the boomerang, but like the other one's flipped up, right? Okay, so that's what he looks like. Keep those parent functions in your head. Now we're going to talk about vertical asymptotes. A vertical asymptote is where the domain poops out.
Okay.
Yep. Where the domain poops out. When you're talking about domain for rational functions, the two things that screw up domain are a negative inside of a square root and dividing by 0. For rational functions, you may have a square root, but most of the time you're going to be worried about dividing by 0. Okay? So, when you have problems with a thing, when you have problems with a rational function and you're worrying about dividing by 0, chances are that when your domain poops out or where your domain has a problem, that's where a vertical asymptote occurs, right? So like, for example, I'm going to go to this function right here, and let's say that this is like y equals 1 over x minus 3, right? Let's say that that's like that function right there. Got it? Okay. This guy is what I'm looking at because I don't want to divide by 0. So in that case, what can x not be equal to? 3, because there is a vertical asymptote that like happens at 3. Okay, and so what your boomerangy function looks like then is like this guy and this guy instead.
It's approaching 3 instead, right?
What?
It's approaching like 3 instead of...
Yeah, it's like going to infinity or negative infinity at 3 or negative 3, right? Or like 3 above and whatever. Your vertical asymptote's at 3. Okay? I'm trying to think what else. Yeah, so he's like doing one of these things. Okay? Now, if your boomerang guy goes in the second and fourth quadrant, so like here and here, that's when you have like negative 1 over x, right? Do we know that? In the second and fourth quadrant, that's when you have a negative in front because it moves him to the second and fourth quadrant instead of the first and third, which is what he normally is, right here and here. Okay, good? But vertical asymptotes, that's like setting the denominator equal to 0. Let me write better. Set denominator equal to 0 to find where the vertical asymptotes are. Okay? So I says identify any vertical asymptotes. Am I going too fast?
Yeah, I can get out paper. There we go.
Identify the vertical asymptotes. I set the denominator equal to 0. So x minus 3 equals 0 and x equals 3. Which means my va is at x equals 3. Which means my domain is that x cannot equal 3. Does that make sense? Okay, so your domain and your va are like opposites of one another. If your va occurs at 3, then your domain is x can't be 3, right? Because it's not touching, right? Okay, for B. Blah. How do I do that?
Let's do it,
What is that?
You gotta make it...
Use a complex trinomial. So we take 3 times negative 2, which is negative 6. Multiply to get negative 6, add to get 5.
5 or 6
3 and 2.
and 1.
Negative 3 and negative 2.
Okay, negative 3 and negative 2 will make negative 5 if I add them together.
Oh, yeah.
So you gotta be careful. Okay?
6 and 1.
And this multiplied will give you positive 6. So I want 6 and 1, 6 and negative 1.
No, yes.
This will add together to give me positive 5, but when I multiply them will give me a negative 6. That's the combination I want. So 3x squared, he comes down. Negative 2 comes down, but this 5 splits into 2 pieces, right? Plus 6x minus 1x. Okay, then what?
Now do grouping.
Now group and group. What comes out of the first group?
3x.
3x. Okay, left over. X plus 2. What comes out of the second group?
A negative.
A negative 1. Left over is
X plus 2.
x plus 2. So my two groups are
3x minus 1.
3x minus 1
And x plus 2.
and x plus 2. Okay, then what do I do?
So to make it 0.
Set them equal to 0. Okay, can you do that in your head? Equals 0, equals 0.
X cannot be number 2.
X equals
Negative 2.
1/3. Is that true? And x equals negative 2. Okay, what did we just find?
That's the va.
That's the va. We have two vas. Okay, we have two VAs at 1/3 and at -2, and that means the domain is that x can't be 1/3 and x can't be -2. You didn't have to say that, but I'm just showing you the domain is where, like, you can't have that for whatever. Okay, got it?
So what's it asking for?
When you have, what?
Just the vase.
It's just asking for the vase. Yep, so you set the denominator equal to 0. When you have two vase, you don't have to write this down, but when you have two vase, like here is at, let me go, 1, 2, 3, 1, 2, 3, whatever. He was at -2, so here's one of my vase. 1/3 is another vase, right? Okay, a lot of times what will end up happening for your function is he'll end up looking like a parabola in the middle, but then he'll have two of these, right? That's sometimes what he will end up looking like. Or sometimes he'll end up looking like this. There in the middle, and then one of these and one of these. He'll do some weird funky things, right? So he kind of looks like the boomerangy things on the outside, but then in the middle is either like a parabola looking thing or an x cube looking thing. Just depends on what type of function you're dealing with. Okay, good? But that's like what it looks like when you have two vertical asymptotes. Okay, all right, C. How do I find the vase? Solve what? How do you find a vase? What? Kind of. Set the denominator equal to 0. X squared plus 4 equals 0. Okay, and then I keep solving. So if I subtract 4, x squared equals -4, and I take the square root.
Guess what?
X equals, what's the square root of -4?
Plus or minus 2.
Plus minus 2i, which means my vase
Alright, math.
occur at imaginary places, which means
There.
no vase. Which also means the domain is
All reals.
all reals, right? There's no vase, so the domain is all reals. Make sense? Okay, so that will happen sometimes as well. Got it? Yeah. Okay, identify vertical asymptotes. For what values is the function undefined? Okay, that's basically like saying where does the domain poop out, right? Where it's undefined. Okay, where does the domain poop out?
So we
Or
need
how do
to
we
solve
find that?
We need to solve that thing.
Okay, yeah, so we set them equal to 0. What is that thing?
Minus. Add the 2 over.
He's a simple trinomial. I don't want to do that.
Okay.
Yeah. Multiply to get -2, add to get -1. X. -2 and x plus 1. Yeah? Then I set those equal to 0. So for what values is the function undefined? X can't be what? We don't want x to be what? 2, and we don't want x to be -1. For what values is the function undefined? For 2 and -1. Okay, then it says write the domain in interval notation. Do you remember interval notation?
No, we don't like it.
Blah. So if I do a number line, I can touch everything except -1 and +2, where I have like open circles. So I have like this thing going on, right?
So.
You can touch everything except -1 and
is it
+2.
brackets brand or unions?
What?
Brackets friends
And unions.
and unions.
So we have three
So
unions because we have 3 chunks.
Negative infinity.
Negative infinity, 2,
Paren.
-1 per in, union,
-1 and
-1 to 2 per in, union, per in,
negative or 2 to infinity.
2 to infinity per in. Okay, not touching any of those values, but it can be anything else, right? You can plug in anything. Okay, identify the vertical asymptotes. Where do those occur?
At 2 and 1 or -1.
At x equals 2 and at x equals -1. Now, I'm going to give you a little heads up. Are you ready for this?
No.
Only one of those is a vertical asymptote, the other one is not. What? No. -1 is the only va.
Why?
Okay.
So
All right, here's a little tidbit. We're going to talk about holes right now, so add this in. Holes. Okay, we're going to talk about a hole in a graph, right? So, what's happening is, let's do this. Let's talk about like the function y equals x. Okay, y equals x is a linear function, right? That does one of these. This is what y equals x looks like.
can we draw that?
Okay, you don't have to, no.
Okay.
Just watch this. Okay, we're gonna talk about holes. So let's say I have this function going on here. That's a linear function, and I want a hole to be right here at 3. Okay, so all of a sudden we're like going along, and then it poops out at 3. Okay, a real world example of this is like, let's say you go into an amusement park, right? And the older you are, the more you pay. So this is your age, And this is the amount of money that you pay, right? Older you are, the more you pay. Except on your birthday exactly, you have a hole because you pay nothing. And then everybody lies and says it's their birthday, right? Okay. So you have a hole on the graph, which means you pay nothing. There's like a hole at that place on your birthday exactly. Okay. And when I want there to be a hole, what I do is I just make this into a rational function and I put x minus 3 on the top and x minus 3 on the bottom. Okay, so now this function is no longer y equals x, it is y equals x squared minus 3x over x minus 3. This is still a linear function. It just has a hole at 3. Okay, so that means that if I have a function where the top and the bottom cancel out, like this guy, what does this top break down into? 3x minus 6? If I pull a 3 out,
Yeah, x minus 2.
x minus 2, okay?
So it's just
Do you see how the x minus 2 cancels out? So that means I only have a VA at x equals negative 1, but I have a hole at x equals 2. Does that make sense?
So you actually like music part, so you can actually get in free on your
I don't know.
Oh, you
I'm
did
just
that.
giving you an example of like how that works, right? Okay, so this function does not have two VAs. It has a VA at negative 1, which looks like this. Boop, 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 boop. And then I have this guy going on here and this guy going on here. That's my boomerangy things. But at 2, which is over here at 2, he has a hole right there in the graph. That's what he looks like. Do you see that? The VA is at negative 1, but he has a hole at 2. Because it canceled out of the top and the bottom, that makes it a hole. If it doesn't cancel out top and bottom, it's a VA. Okay? But you have to be very careful because sometimes the holes are hiding and they look like VAs to begin with. But you got to factor the top down and make sure he doesn't cancel. We'll do a lot more of this. Okay? So, really, the vertical asymptotes are only at negative 1 because this guy is a H-O-L-E. He's a hole instead. Okay? Get it? A hole in the graph. It's like where you're going along and all of a sudden it's like an open circle. Okay? Good? Whew. That was a lot of information.
We need to stop
Yep. I'll pause for a minute.
for the day. For 24 hours.
Do they talk about holes anywhere? They don't. They don't. They don't. Okay, let's do this. I'll stop there, but we're going to do one more thing off to the side over here. So write this example down. Bloop. Over here somewhere. Example. Okay, we're going to find 3 different things. Let's say I have the function y equals x squared minus 4 over x squared plus
Make it nice.
5. No, there we go.
That's not nice, Chloe.
That's not that bad. Okay. All right, we're going to find 3 things. We are going to find the zeros of a function. We're going to find the VAs. And we're going to find the holes, if any. Holes. And then we're going to find the domain.
That's 4.
We're going to find those 4 things. Okay? Blah. Okay, how do you find a 0? What is a 0, by the way? It is x-intercept. How do you find an x-intercept? Set y equal to 0. So I put 0 in there and I have to solve for x. Okay? How do I solve for x if y is 0?
Well,
What?
the great question.
Top's imaginary.
No, it's not. No, it's not. How do I solve for x if I have 0 over there? What would you like to do first?
What?
X, that's the difference of squares.
Right.
Shed.
Not yet. Just wait. What?
Okay.
Break the bottom.
No, I don't want to break anything down.
What?
Not yet. Not yet.
Then
Not
do
for the zeros.
nothing.
You multiply it.
Can I multiply the bottom over? That's what Matthew wants to do. Is that what you wanted to do, Matthew?
Yeah, I want to.
Yeah, I want to get rid of the bottom, right? Can you get rid of the bottom by multiplying it to the other side?
Yes.
X squared plus 5x minus 14. Guess what? What's 0 times that junk?
Nothing.
0. Okay, the whole bottom goes away. Boom. Okay, then what?
Can we?
Add 4. 4 equals x squared. Take the square root. What are the zeros?
I wrote plus 4.
Plus and minus.
Plus and minus?
Yeah.
2. That's really nice. Okay, so the zeros are positive and negative 2. I'm going to do a little sketch of him over here. If you want, you can do the same. Positive 2, touching. Negative 2, touching. There he is. Okay. Maybe. For now, they're touching it. That's fine. Okay. All right, vase. Vase is setting the bottom equal to 0. Okay, but we got to do something with the bottom.
Let's, break it apart.
Break it apart. He's a simple trinomial, right? Multiply to get negative 14, but when you add them, give you positive 5. What do you got?
7 and 2.
X plus 7, x minus 2. Yeah? So that means x equals negative 7, and x equals positive 2.
Those are vase.
And those are vase. X equals negative 7. Maybe vase. Right? They both look like vase right now.
Well, the 2 isn't.
Ooh. Okay, why is the 2 not?
Because we factor that's a 0.
Okay, if you factor the top, somebody said difference of squares. If you factor the top, this is x plus 2, x minus 2, right? So, the x minus 2's cancel. So that means
A whole at 2.
there's a hole at 2, right? At 2 right here, this is actually a hole instead. So the only va that I have is negative 7, okay? All right, so I'm going to go over to negative 7. 1, 2, 3, 4, 5, 6, 7. There's my va. And this guy has a hole at 2. So this is not an open circle. Or this is not a closed circle.
Open circle.
This isn't actually an open circle, right? For my graph. Does that make sense? And I don't know what else he looks like. He might be doing some weird stuff like my horizontal asymptote is at 1. You don't know how to find that yet, but you will. So he looks like this. And I don't know, he's doing something like this maybe.
You just found
I don't know. The horizontal asymptote's easy to find, but we'll wait to do that tomorrow. So there's that. So as far as domain goes, what can x not be?
Negative 7?
Negative 7.
Positive 7?
No, x can't be negative 7, because that's what my bottom is, right there. But what else can x not be?
2.
2. Doesn't matter that it's a hole. The domain is holes or vase. It's where your x doesn't touch. Does that make sense?
That's nasty.
Yeah, that is kind of
I
nasty.
don't like it.
Okay? Good? There we go. Okay. All right, you should be able to do, I have no idea how much.
Until 36.
Up until 36. Perfect. So you got a little bit. You got a little bit to do. Let me mark that. Let me mark that right here. Up to 36 or past 36? 236.
Write the domain
Right there.
in arrow notation.
Yep.
There.
Okay? All right, there you go. People who are gone.